Okay, so our class will be start at 2:30. All right, so we have another 1 minute. So and then we start our class lah. Okay, at 2:30. Okay, all right. So let's start our lecture for today. Okay, so can see my slide?
Yeah, there.
All right, right. So okay, Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to all of you. All right. So today, if you can see on my slide, so we try to finish on the component of fuzzy logic lah. So this is last part of the component inside the fuzzy logic that we call the defuzzification. All right. So the defuzzification will be convert back from the fuzzy set to the classical, or sometimes we call the actual value or clip set value. So before I explain on the defuzzification, so let refresh what we learned last week. So okay, so this is some example are given on the groups. Okay, you can see this one. So first, okay, can you see this slide? Boleh nampak slide exercise 1?
Boleh ada.
All right, okay, so let's try this one. So to refresh what we learned last week. All right, so the exercise 1, okay, so we have the membership. Okay, we have the fuzzy set A, we call the fuzzy set A, and then this one is a fuzzy set B lah. Right. Okay, so first evaluate A. Okay, A intersection with B. So this mean we have to select the minimum. Okay, we have to select the minimum lah, and then you have to compare the sequence. For example, okay, A intersection with B. So the first sequence is the 0.1. Okay, 0.4. Sequence number 2. Okay, sequence number 3 will be 0.7. Okay, 0.6. Okay, you have to compare this one. Okay, for example, sequence number 1, you have to compare with sequence number 1. Okay, so if we do the operation of the intersection, this means we have to select the minimum. Okay, we have to select the minimum and make sure you have to compare the same sequence. For example, sequence number 1 with sequence number 1. That's why 0.1 and 0.2, which one the minimum? So the answer is the 0.1. Okay, 0.1. Okay, sequence number 2, 0.4, 0.7, 0.6, okay, 0.5, okay, 0.3, and 0.1. Okay, so this is for operation of the intersection. Okay, for next, if A union with B, that means we have to select the maximum. Okay, we have to select the maximum. Okay, but you have to make sure compare the same sequence. Okay, for example, sequence number 1, 0.1 compare with 0.2, sequence number 1. So the answer will be 0.2. 0.2, 1, okay, 0.8, okay, 1, okay, 1, 0.7, okay, 0.4, and 0.1. Okay, so make sure this is you have to compare with the same sequence. Right, so you can use this one. Some of the question maybe you put as the add symbol. This one for the symbol. It's not you have to add. For example, this is some mistake. The previous student, so they put another one. So we compare this one. After do the comparison, it's okay. And then the student add this one 0.1, add 0.4, 0.7, 0.6 until so on lah. They get something result this one for example x lah. So this is wrong So this operation is not the you have to add. This one is just a symbol, okay? Symbol. For example, for the next sequence that's why I put here. I put a comma so that you clear this one So before this, maybe you can put also plus this one that I mentioned to you. Plus is just a symbol, right? It's not operation That's why you have not operation. You have to add all the value here. Okay, it's just a sequence. Similar like this one Similar like this one pun also that I put comma lah, semicolon, comma, and so on lah. Alright. So next is the complement of A. Complement of A is equals to 1 minus quasi set A lah. Okay, this one also straightforward. Okay, on the sequence number 1, 1 minus 0.1, 0.9, sequence number 1, okay, 0.6, okay, 0.3, 0, okay, 0.3, 0.6, 0.9, okay, that is a sequence number 2, number 3, number 4, 5, 6, 7, okay, that is the answer, right? So this is for complement complement of A. Okay, that means 1 minus of fuzzy set A lah. So every sequence you have to minus with 1 For example, 1 minus 0.1, 1 minus 0.4, 1 minus 0.7, 1 minus 1, okay, 1 minus 0.7, and so on. Okay, that is the answer lah. Okay, this one. Alright, so let's go for another exercise. Okay, this one, okay, similar like before this. Okay, this one is the complement of B. This means 1 minus fuzzy set B lah. This one maybe we can put as the fuzzy set A, fuzzy set B. Alright. Okay, so the answer will be this one straightforward. You can okay, this one 1 minus okay. Right, you can see this one So fuzzy set B. Okay, 1 minus 0.3, 0.7, okay, 0.4, okay, okay, this one you can see missing on the sequence number 3. That's why here actually we have sequence number 3. Sequence number 3 is 0. Okay, that's why if you want 1 minus 0.3 will be 1. Okay, will be 1. Okay, 0.45, 0.22, and so on. Okay, so this is sequence number 1, sequence number 2, sequence number 3, sequence number 4, sequence number 5. Okay, you can see this one. So normally student missing here. Okay, missing on the sequence number 3. That's why on the if we have for example, so not mentioned here. So actually we have some value here. For sequence number 3, actually we have 0 membership value for sequence number 3. That's why if you do the complement, okay, so 1, 0, okay, so that's why the answer will be 1. Okay, that's why you have to put again. Alright, so this is some kali mistake lah, and then this is some tricky equation lah. Just missing on the maybe on the for example like this one sequence number 3. Just so normally you can assume sequence number 3 will be 0. Okay. Similar like this one for example, okay, if you do the graphicals, okay, so for example this is B fuzzy set B. So if you do the complement of B, okay, B complement, okay, the answer should be like this alright, so like this, okay, like this, and then actually we have here, okay, that's why before this one is the 0, 0, 0, 0. Okay, this one actually is a 0 value. That's why if we do the complement, that's why this value actually is SSR. For example, this is sequence number 1, sequence number 2, sequence number 3. That's why sequence number 1 will be 0, sequence number 2 will be 0, for example. Okay, so one sequence number 3. Right. So that's why here when we do complement, that's why this value is exists actually because of 1 minus 0 actually will be here. That's why we can get the answer is the 1. Okay, this is the complement of B. Okay, this is complement of B. Right, and then next, okay, first after you do the complement of B, so you can do this one. So A intersection with complement of B. That means we have to select the minimum. We have to select minimum lah. Okay. So okay, this one. First, you have make sure you select the same sequence. Okay, this one 0. Okay, sequence number 1 0.7 and this one missing on the sequence number 1. So suppose this one will be 0. Sequence number 1. So the answer will be 0. Sequence number 1. So we compare the B complement of B, A and complement of B lah. Alright, and then for example sequence number 2. Sequence number 2, this one and this one lah 0.09. So the answer will be 0.09. Sequence number 2 and so on. Okay. Then sequence number 3 lah. Sequence number 3, okay, 1 and this one also missing. Okay, so this is sequence number 4. So sequence number 3 will be 0, 3. This one. Suppose, okay, this is 0, sequence number 3. So you have to compare, select the minimum. So 0, sequence number 3. Okay. Then so on lah. Okay, the rest you can try lah. Right, please make sure you have to compare the same sequence. Same sequence. This one, okay. So with sequence number 2, this one. There is another mistake lah. Normally student the simple kali mistake student compare with this one. So something like this, straightforward. Okay, but please make sure with the same sequence. If not, you cannot compare directly like this lah. Right? So there is some mistake lah before this. Okay, that's why you have to it easier, but simple to do the kali mistake. Okay, that's why if you do comparison, make sure on the same sequence lah. For example, sequence number 5, okay, with sequence number 5. Okay, sequence number 6 with number 6 lah. Alright, so for example, okay, for example like this one, sequence number 3. This one is actually we have 0 lah. You can put or you cannot put. So that's why I just some tricky question. So I just miss one value here. So that means if not given, normally the value is 0. Okay, if not given, for example like this, the value is 0. Membership value is a 0. Okay. Similar like this one. So it's not given on the 3, also 0. Okay. And then this one, okay, you can do this operation first. Okay. For example, this one is a tricky question. So first you can do this operation. Okay, A, this means you can do this operation first. A union B, that means you have to select the maximum. Okay, after you get the answer, okay, then you can do the complement lah. 1 minus this one lah. 1 minus A intersection with B. Okay, for this answer. Okay, this one you can do this operation first. Right, then you can do the complement. Okay. Right. So next, okay. So this is on the inference. On the inference engine. So before this, we have studied about the inference engine. So on the class, we have the Mamdani. Okay. So this is the Mamdani max min. Is the Mamdani. And then this one, the max is the Laksana. Okay. Right. First, you can see the relation. So for example, like max min, right? Y equals to x dot r. Okay. This one also the symbol. It's a symbol. It's not the operation. It's just the symbol, and then the operation based on this one. The operation is the using the Mamdani. For example, like this one. This one is just a symbol. Just to differentiate which one the Mamdani, which one the max. Okay, the max. It's just a symbol. Also, I can put like this. I can symbol same. Okay, that's why I can put like this one, similar like this one. Okay, but please make sure is the operation is, for example, this one is the max. Okay, max a product, that means we use the Laksen. Okay, if you use this one, same, but we use the for the Mamdani. Okay. Alright, so first make sure follow the same the correct relation. X dot r. Okay, x dot r. So this is another mistake lah. Student put like this. First put, for example, like this one. Is the first is r, and then student put like this. Okay, 0.3, 0.8. 0.3, okay, and so on. So that means this distribution, it will be r dot x, okay. It's not similar like this. That's why first make sure you set the relation lah. That means x first, x first, then r, okay. That means you have to put r here lah, okay. 0.3, 0.6, 0.5, okay, 0.8, 0.9, 1, okay, 0.5, 0.1, 0.2, okay. Alright, so for if you use the Mandani, for example, we want to calculate the R11 here, R11, okay. So that means this row compare with this column lah. Alright. First for Mandani, we have to select the minimum lah. Select the minimum. For example, 0.3 and 0.3. So the minimum is 0.3, right? So and then 0.8, 0.6, 0.6, right? 0.9, 0.5, 0.5. All right. Then we have to select the maximum. Okay. The answer is 0.6 lah. Okay, that is for R11. For next, we try to another R21. Okay, R21. This row compare with this column, right? So for example, 0.8 and 0.8, right? So 0.8, the minimum is 0.8, 0.5 and 0.9. So 0.5, okay, 3, 0.3 and 1 is a 0.3, okay, and then select the maximum lah. Select the maximum, the answer is 0.8, okay. Then for example, next 3.1 lah. 3.1, this row and this column lah, okay, compare with this column. So 0.3, 0.5, so the minimum is 0.3, okay, 0.7, 0.1, 0.1, okay, 0.5, 0.2, 0.2, okay, then select the maximum lah. The maximum is 0.3, okay. Alright, so this one when we use the max min, max min, that means we use the Mamdani lah. Alright, okay, clear guys,
Clear there.
Alright, so if you use the Laksen, alright, so Laksen, okay, this one, first make sure the relation lah, r dot x, okay, that means r dot x lah, okay, suppose like this lah, 0.3, 0.8, 0.5, 0.7, okay, 0.9, 0.3, 0.5, okay. So the normal mistake, okay, student will be follow the previous. For example, okay, that's the normal mistake. That's why you have to check this one, check the relation. Okay, that is very important. Okay, this is a simple mistake from the previous lah, previous. So check the relation lah. So normally student do like this. Okay, the previous. Okay, for example, the first relation x dot r, and then next student will be follow the same. Okay, x dot r will be put x first, then r. So will be wrong. Please make sure the relationship for the equation are given here will be r dot x. Okay, that means you have to put r first. Okay, the metric r first here, then x lah. Okay, for calculate the R11 using the Laksen. Okay, for example, similar like this one, this row, okay, you have to multiply with this column. Okay, for example, 0.3, 0.3 multiplied by 0.3, okay, then 0.3 multiplied by 0.3, okay, compare with 0.8 multiplied by 0.8, okay, and then 0.5 multiplied by 0.3, okay, for example, this one 0.09, okay, 0.64 for example, and this one, okay, 0.15 for example. So the answer will be the maximum. After you multiply 0.3 multiplied by 0.3, and then 0.8 multiplied by 0.8, 0.5 multiplied by 0.3, then you can select the maximum, which one the minimum. For example, this one 0.65 lah, sorry, 0.64 for example, okay. Then select the maximum. First you have to multiply for the Laksen. First multiply, then select the maximum. For example, for the next, okay, for the R21 here. So this row multiply this one. For example, 0.6 multiplied by 0.8. Okay. Then 0.9 multiplied by 0.5. And then 0.1 multiplied by 0.7. Then you have to compare lah, which one the maximum. Okay. Which one the maximum? That is the answer for R21. Okay. That is the answer for R21 lah. Similar like R31. R31, this, okay, this row multiply by this, compare with this one lah. Okay, first you have to multiply 0.5 multiplied by 0.9. Okay, you can use your calculator, and then 1 multiplied by 0.3 here. Okay, 0.3. Okay, and then 0.2 multiplied by 0.5, and then you have to compare which one the maximum. That is the answer for R31 lah. Okay, right. So this is on the inference engine lah. Okay, this is on the inference engine. They use the metric. Okay, this one using the metric. Right. So next you can see on when we use the graphical. Okay, this one we use the graphical. So that's why actually similar like this. Okay, this one before this. Okay, this is on the, we call the metric. For example, okay, we have this one. For example, this is, we call the input one. This is input one, and then this is input two. Okay, all right. So on the input one, we have membership. Okay, this is a membership one. For example, this is membership 2, and this is membership 3. Okay, if you convert into graphical, maybe similar like this. Okay, this is some example. Some example. Okay, something like this. Okay, so this is a, for example, we can set as the, this one as the A, this one B, this one C. So this one we can set as the A, B, C. Okay, this one on the graphical, and this one using the metric. Okay, metric number. Okay, similar like this one. So this one for input 2. Input 2, we have, for example, here we have A, B, C. Okay, we have the membership A, membership B, membership C. So in convert into graphical, maybe similar like this. Okay, this is some example lah. Okay, so that's why, okay, we can put this one A, so we set A, first set B, first set C. All right, so this is on the graphical. On the graphics, this is on the metric lah, using the metric. How they are put. Okay, this is on the matrix, and this one on the graphical lah. So if next, this one, okay, this one on the inference. Okay, first make sure the operation. Okay, for example, this one we use the max min. Okay, we use the max min. That means we use the Mamdani. We use the Mamdani. All right, for using the graphical. All right, that's why you have to check the rule number 1. Okay, rule number 1. For example, A11 is a 0.8. Okay, and then to 0.4. Okay, the operation we use the OR. Okay, we use the OR. That means that I mentioned to you, if you put this is connection here. So if you use the OR, so automatically we have to select the maximum. Okay, we have to select the maximum. Okay, from this one we know that 0.8 and 0.4, the maximum is 0.8. Okay, from this one, okay, to the, okay, oops. Okay, all right, similar like this. Okay, you can use your ruler. Okay, right, so you get like this. This one 0.8. Okay, this one we know this is 0.8. All right. Okay, so our output, if you use the Mamdani, so automatically that I mentioned to you. So this is our outputs for B1. Okay. Okay, right. So maybe I draw this. Okay, this like this lah. All right. Okay, this one is negative 0.3. This one 1.7. Okay, this one is a 0.8. Okay, this is our output B1. Okay, B1. All right. So next we follow this one for rule number 1. This one rule number 1. The connection is OR. Okay, we go for the next. Okay, next rule will be we use the AND. Okay, use the AND. That means we have to select the minimum. Okay, we have to select the minimum. Okay, we have to compare lah 0.7 here and 0.85. Which one the minimum? So the answer is 0.7. Okay, from the 0.7 using your ruler, so will be right. So will be like this lah. Okay, this one we know is a 0.7. This one 0.7. Alright, so this is our output for B2 lah. Okay, so if I draw here, so it will be like this lah. This one, -1 and 1. Alright, so this is a 0.7. Alright, okay, so this we call the B2. Alright, so this is not complete yet. So the total one, actually you have to add all the B1 and B2, all the output for the every rules. For example, the B total is B1 plus B2 plus B3 and so on. So if we have 12 rules, that means you have B total, you have to add lah B1 plus B2, B3 until 12 lah. For example, this one only, okay, this is some example B1 plus B2. Okay, so the BT you have to add this one lah. So this is we call the B total. So we draw again. So this one something like this. Okay, this is negative 0.3. This 1.7. Okay, this one negative 1. So maybe like this. Okay. Okay, this one 1 and this one is the negative 1. So this is total lah. Okay, this one we call the B total. Alright, so this is last answer. Okay, this is last answer. So the previous mistake, normally student do the B1 and B2. So student forget on the B total. Alright, so that's why you have to get the outputs. Last output we call the BT. Okay, B total lah. That means B total. So if you have two rules, that means you have to add, okay, B1 plus B2. Okay, if you have 3 rules, that means you have to add B1 plus B2 plus B3. Okay, and then you get the B total here. So this is the output for BT. Okay, right. So this one using the Mamdani. Using the Mamdani. Okay, so next we try to use the max. Okay, the Laksana. Alright, so this is how to use the first operation. Make sure you have to check the operation. So either you use the Mamdani or Laksana. For this case, we use the Laksan. We use the max a product lah. Okay, use the Laksan here. Okay, so on the metric we know. So if you use the Laksan, that means we have to multiply, then select the maximum. Okay, that is used on the metric. Okay, similar like for example like Mamdani, using the metric, first you have to select the minimum, then you have to select the maximum. Okay, this one using the graphical. Okay, if you use the graphical, so okay, the first rule you have to check this one, the operation. Okay, the operation. Okay, second you have to check on the connection between input 1 and input 2. Okay, this one we call the input 1. This one input 2. Okay, this one input 1, input 1, input 2, input 2, input 2. Alright, and then you have to check the connection. Okay, either use the OR or use the AND. Okay, for example, this one use the OR. Or you have to select the maximum. Okay, we have select the maximum. So you can check this one. So we can compare the rule number 1, 0.8 and 0.4. Okay, we select the maximum. That means here will be 0.8 lah. Okay, maybe from I can use a ruler. So this okay. This one 0.8 for example. Okay, all right. For example, for the Laksan, you have to put on the this is the center. All right. So from this set point, you have to write to the center lah. Right. So from this point 0.7 to this point lah. Okay, intersection this one. Alright, so this is our output for B1. Okay, so this is I draw again here. So it will be like this lah. 0.3, 1.7. Okay, this 0.8. Okay, so this is our output for B1. Okay, this one for B1 lah. Right, and then for rule number 2. Okay, rule number 2, check the connection. We use the n. We have to select the minimum. Okay, so that's why you have to compare lah 0.7 and 0.85. So the minimum is the 0.7. So from 0.7, okay, you do like this. Okay, then you can, okay, from this intersection you can write here, okay, and then okay, sorry, okay, this is our output. Okay, this one will be, all right, so I draw here. So this one will be negative 1, 1. Okay, this one is 0.7 Okay. Okay, this one 0.7. Okay, B2. Right, so the third rule, you have to draw the B totals. Okay, B total. Number 3, you have to draw the B total lah. That's why you have this. You have 3 steps. First, check the connection. Check the operation. Using the Mamdani or Laksen. Second, check the connection. Okay, whether use the or ends. Okay, third, you have to B total. Draw the B totals. Okay, this one is not complete lah. This one, okay, for example, B1, B2 is not complete. You have to get the B total. So the B total B1 plus B2 lah. Or sometimes we can use the B1 union with B2. Okay. And then you have to add lah. Maybe draw again. So this one. So this one 0.3, 1.7. Okay, 0.8. Okay, this one maybe 1. Okay, this one 0.7. Okay, this one minus 1. Okay, so this is our B total. Okay. Alright. Class clear this one, So make sure. Alright. So make sure for this one on the inference engine, normally we have 2 techniques. Okay. We have used the Laksen or we use the Mamdani. So if you use the Mamdani, make sure our output will be like this. Okay, Mamdani will be like this, similar like this. So we have the here. Okay, non-unique. Okay, this one. For example, okay, this is for example like Mamdani. Okay, this one Mamdani. Okay, this one Laksen lah. If you use the Laksen, that means our output will be, we have the max here. Okay, we have the max here. Okay, so there is a difference between the Mamdani and Laksen lah. Okay, alright. From this output B total, alright. So that's why we have to using the defuzzification, alright, to get the last output lah. Alright. That's why after this we go for defuzzification lah. So this output, okay, this output B total. So we go for the next, okay, the next operation is the defuzzification. So we will cover for today, alright. So to get the last output lah, what is the last output for this one? So, okay, so after we get this inference engine and compare with the rules here, so and then we get the B total. So the last part we have to use the defuzzification lah, defuzzification technique to get the last output, the actual lah, the actual value lah. go to our system. Okay, that's why today we go for the defuzzification. After we get the B total here, okay, that's why we have to use the defuzzification technique to get the last output lah. Okay. Okay, so today we go for the defuzzification. Alright, so this is last component for the fuzzy logic. This is the defuzzification. Alright, so that I mentioned to you, the fuzzification is the mapping from the space of the fuzzy control action defined over an output universe of discourse into the space of non-fuzzy crypt control action. So for the simple definition is the fuzzification is to process or to convert from the fuzzy set to crypt set or to actual value or sometimes we call the crypt value. Alright, so this process is necessary because in many practical application the crypt control action is required is to actuate our plan. So normally go for our plan, okay, is the actual value. Okay, for example, dimension to you. So this is our fuzzy. Okay, this is our. Okay, so this is our fuzzy architecture. For example, this is our fuzzy architecture, and then this is our system, our plan. Okay, this is our feedback. Okay, and this is input, and then this is output. Okay, and then this is we have a feedback here Okay, we have a feedback here. Right, so here so that's why you can see this one the function first. This one is the on the actual. Is the actual value actually. So go for the fuzzification. So on the fuzzification, we have to change to fuzzy set here Alright, so this is process on the fuzzification. Okay, we have to convert from the actual value here to fuzzy set or fuzzy value. Okay, on this one will be on the fuzzification So and then go for the inference engine. Okay, so on that mention to you, inference engine we have the Mamdani or Sugino here, and then to get the output here. Okay, for example, like this, we call the B total here. Okay, the output for fuzzy, we call the B total. Okay, and then we have to convert back to the actual The actual value will go to our plan or our system That's why the function of defuzzification is to convert from the fuzzy, okay, the fuzzy set or the fuzzy value here to actual value Okay, the B total that we calculate, okay, that we draw before this, B total, and then we convert into the actual value. What is the actual value? For example, we put the sum Z value here. Okay, what is the Z value to get to enter to our system Okay, that is the process on the defuzzification. Okay, so the defuzzifier also perform an output denormalization if the normalization is performed in the fuzzification module. Right, so before this on the MATLAB before this on the software on the MATLAB we use on 2006 2006. Now we have the latest one the advance of the MATLAB 2019 2020. So before this, for example, our output will be this is graphicals. All right, so before our output will be maybe on the zeros until 100. For example, is our speed for example, this is our speed. Okay, so before this on MATLAB 2006 we cannot do this output. Okay, we cannot do this output because of the limited on the software So we have to normalize. Normally we put like this. Okay, normalize 0 to 1. Okay, 0 to 1. But that means this one equivalent to 0 and 1 equivalent to hundreds. Okay, maybe here, for example, is the 0.5 equivalent to 50. This one we call the normalization. Okay, this one is the actual, for example, actual, and this is go for the MATLAB Okay, this one we call the normalization. Okay, if we do the normalization on the fuzzification, okay, for this process, so we have to do the denormalization on this part lah. Okay, but the better software on the MATLAB, so we can use this one. Okay, nowadays I think start on the 2009, 2000 above, we can put our input will be how many? For example, this speed will be until 1000, 2000. We can put from the range. Okay, the range is from 0 to 1000, 2000. Okay, because of the better software lah. Before this, for example, like MATLAB only allow -1 to 1. Okay, before this, before this 2006.
Hello.
Yeah, yeah.
不可以，我要灭掉老师。
Hello. Okay. So before this, that mentioned to you, so before this, MATLAB allow only value for the input -1 to 1. Before this, I think 2006. So now better software on the MATLAB, so they can allow from 0 to 1000, or for example, we have 2000 and it's go for infinity to infinity lah. Okay, because of the, so that's why the normalization is not no, that's why we not cover on the normalization lah. Okay, because of the better software. So before this, we have to do the normalization lah. If we do the normalization on the falsification, and then from the defalsification, we have to normalize again. Okay. All right. So there are many methods of the defalsification that have been proposed in recent year. All right. Unfortunately, there is no systematic procedure for choosing the defalsification strategy lah. Right. So no systematic procedure. Okay. So actually, that mentioned a lot of method in the falsification. So, but in our class, we just focus on the 4 most common falsification method lah. Okay. So we cover on the max membership methods. Okay. Center of gravity methods. Okay. Weight average methods. And another one is the min max membership method. Okay. So for our class, we just focus the 4 most common defalsification method lah. Okay. Max. Okay. We call the max. Center of gravity. Okay. Sometimes we call the centroid. Okay. Centroid is similar like center of gravity. Sometimes they use the centroid. Okay. Actually, centroid is the center of gravity. Okay. And then we have the weight average methods and min max membership method. Okay. So next we go one by one. Okay. So the max. Okay. We go the first defalsification method is the max. Okay. So this scheme is limited to the peak output function. All right. And then this method given by algebraic expression lah. So automatically, okay, for example, this is our output. Okay, this is our BT, for example, okay, before this. Okay, this is our BT, and then this is max. Okay, from this one, we just this is our Z. Okay, for example, this value is 2 to 4 lah. Okay, for example, and then this is 3.2. Okay, so our output Z star is the 3.2. Okay, this is some example lah. So this 3.2 go for our system lah, go our plant. Okay. Okay, go for our plant to our system, right? So this is straightforward. If you use the max, okay, this is straightforward. Okay, like this. Okay, maybe I show some example here. Okay, so okay, like this. Okay, this is our BT. Okay, that means maybe we have combination between for upper B, okay, for example this. Okay, this one is the ones. Okay, and then we know this is the max. Okay, this is the max, the highest one. Okay, and then we go here. So this is actually is our output. Okay, Z, the Z star here. All right, for example, okay, this one 0 to 10. Okay, here maybe is a 5. Okay, that's why our Z output will be 5. Okay, so this value go for our system lah, our plant. Okay, all right. So maybe another example here. Okay, we have okay, for example like this. Okay, 0 to to 10. Okay, this one. Okay, maybe we put 2, 4, maybe okay, 6. This one 8. Okay, all this one will be okay 1. Okay, so this one, what is the output for this one? Okay, this one, what is the output for this one? Anyone to try? What is the output for this one? Okay, what is the Z output? Okay, Z out star here. What is the Z out star here? Anyone to try? Okay, class. So what is the output for this one? Okay, for this one, what is the output? 2, 4, 6, or 8? Which one? Okay, if for example, if this happen on this, actually is our B, so this one we cannot use the max. Okay, we cannot use the max. Max is the invalid because we have 1, 2, 3, 4. Okay, that's mean suppose only one only one value only one value. Okay, so this one we have 2, we have 4, we have 6, we have 8. So for this one, we cannot use the max membership. Okay, this one we cannot use the max membership. Okay, for maybe we have another example here. Right, so we have here. So automatically, for example, we have one here. So here we can use the max because we have the only one highest. Okay, only this one, the highest. Okay, the highest max lah. So that's why this is our output. Okay, clear? So for example, like this, we have, for example, we have 2. Okay, this one maybe like this. Okay, maybe like this. Okay, so maybe we have 2 here. Okay, the same peaks. Okay, so this one we cannot use the max. Okay, because we have 2 value for the max. We cannot use the max membership method. So there's one. If you get the output B total here, we have more than one value. Okay, for the Z output, so this one cannot valid lah. We cannot use the max. Okay, we can use another technique lah. Okay, right? So this is for the max. Okay, this is for the max membership method lah. Okay, for max is the straightforward. Okay, straightforward lah. See the which one the max and then get the output lah from this point to what is the output here. Okay, this is universe of discourse lah. What is the value for universe of discourse? Z star here. So this is our output lah. So this Z star will be go for our system to our plan lah. Alright. So this is for the max membership methods. Alright. Next. Okay. Next is the center of gravity lah. Okay. Center of gravity, or sometimes we call the centroid. Okay. So this procedure is the most prevalent and physically applying of the defuzzification method lah. So normally we use this one okay, because of the center of gravity, we calculate the area under the graph lah. Area under the graph luas di bawah graph lah. Alright, so it's given by the algebraic expression. Alright, this one okay, so this summation of membership. Okay, membership Z multiplied by center. Alright, and then divide by summation of membership. Okay. Okay, so this is on the equation lah. We have to integrate. Okay, integrate this one dot Z dz. Okay, Z dz, and then divide by integration of. Okay, so this one we have this example or no? Okay, so no. Okay, maybe I show this example here lah. Okay, so this point, maybe we can put some point here. So this one maybe we can put 2, right? So this one maybe you can put as the 4. Okay, this one maybe you can put as the 5, for example. This one is the 7. This one 8 lah. Right. So the first you have to get the equation here. Okay. Remember the first chapter the first chapter on the fuzzy logic, you have to calculate we put some output here. Okay, so the formula for this equation will be Z minus z, this one we put as 1, okay, minus 1 divide by 2 minus 1. Okay, this equation, okay, this equation, okay, z minus 1, okay, z minus 1, we put some z here, okay, divide by 2 minus 1, right? So this is equation for this one, right? So this one no need lah. This one is the membership value is the 1 lah, okay. Okay, for example this one, okay, this one, okay, maybe you can put like this, okay. Okay, this one maybe you can put as a 6 lah, okay. So we put this one actually is the negative negative equation, but on the membership value, so we don't have the negative. So the equation we put some z here. So z minus 4 divide by 6 minus 4. Okay, clear, eh? So this one, so also it can, this one also can similar like z minus 4, okay, divide by 5 minus 4. Okay, this one, we put some, normally we put this one from this equation, we put this from this one, the equation is 6, that's why we put 6 minus 4. Okay, and then this part will be constant, so will be constant, for example here 0.4, so will be 0.4, 0.4, and then next last, for example this one, okay, we put some z here, okay, the answer will be, okay, sorry, so this one, okay, sorry, this one, suppose like this, okay, this one, sorry, so this is negative, also you can do like this, or suppose it's the negative, all right, this is negative slope, and then for the membership value we don't have the negative, suppose 6 minus z divide by 6 minus 4. Okay, similar like this one, 8 minus z, okay, 8 minus 7. Okay, this one, okay, or this one actually will be same with this one, okay, that's why it will be same. Okay, after you integrate, we get the same answer. Okay, this one already proved by previous student. So if you use this one, also same use this one Okay, for example, we put like this For example, this is for the negative slope negative slope. So 8 minus z, 8 minus z divided by 8 minus 7 8 minus 7. Okay. So next we will try this one how to solve this one. But I will go for the next, okay, the next method first, okay, because this is involved of integration, okay, integration, so we have to integrate, for example, okay, the first example, integrate from 1 to 2, okay, and then next plus 2 to 4 and so on, okay, this one we will be trying next, okay, so I proceed for the next, okay, the next method is the wedge average method wedge average method, okay, so this method only valid for the symmetrical output membership method, so symmetrical, okay, so this valid for symmetrical make sure the symmetrical when we divide by 2 is the same, okay, is the same size for example this one so for example this part we divide by 2 will be same with this part okay, this one also same we divide by 2 will be same. This one, that's why we call this symmetrical. So this is symmetrical Okay, valid for symmetrical. For example, we have like this. Okay, so this one is the, for example, is 2, this one 6. Alright, so this one, if we divide by 2, it's not symmetrical. So this one, we cannot use the weight average. Okay, this one we cannot use the weight average. Okay, weightage average. So this one we cannot use that, not valid. Okay, because of not symmetrical. So if symmetrical, so this the output will be like this 2, 4. Okay, for example. Okay, this one 4. Okay, this one we can divide by 2 So this part and this part will be same. That's why we can use the weighted average. But if this one, so it's not symmetrical with this one. Okay, so this part and this part is not symmetrical. So that's why we cannot use the weightage average lah atau weight average. So this method is valid for symmetrical output. Okay, symmetrical output. You have to remember. Okay, this method only valid for the symmetrical membership function. Okay, for example, this is our BT. Okay, we got the BT here. So and then we have to check lah whether this part and this part will be same, and this part and this part will be same or not. If same, so we can use the weighted average. If not, for example, like this. Okay, maybe we have either like this. Okay, the output will be this one. Oops. Okay. Right, so this one is symmetrical, but this one is not symmetrical, so you cannot use the weighted average. Okay, so all the output will be symmetrical lah. Okay, symmetrical. So only, okay, this one is not symmetrical. For example, if divided by 2, it's not this part and this part is not same. Okay, for example, this is B1 and B2. So if only B2 symmetrical but B1 is not symmetrical, you cannot use. Okay, also you cannot use the weighted average. Okay, you cannot use the weighted average method lah. Alright. Okay, so the formula for algebraic operation for the weighted average is like this. Summation of, okay, this membership value. Okay, membership value multiplied by center. Okay, this we call it Z1. Okay, this 0.8 for example, 0.8 multiplied by Z1 plus 1 multiplied by Z2. Okay, divide by membership value lah. Membership summation of membership value. For example, like this one. Okay, this is an example. Okay, I put Z1. Okay, 0.8 multiplied by Z1 here, Z1 here. Okay, and then plus 1 multiplied by Z2. Okay, here here is the center, Z2 multiplied by membership value is 1. Right, divide by membership value 0.8 plus 1. Okay, and then we get the Z total lah. Okay, Z total here. So Z total we will go for our plan. Right. Okay, next, the last technique for the diffuzzification is the min-max. Okay, min-max membership method. So this method is closely related to first is the max. Okay, is related to the first method lah. We call the max. Okay, except the location of the maximum membership can be non-unique. Okay, for the max is the unique. Okay, is the uniques. That means for the max, okay, max membership we have, for example, like this, only one maximum. Maximum. Okay, for this is using the max. Okay, for the means we have only one non-uniques. Okay, but the highest lah, the highest one. So this is we call the non-unique. Okay, for example, if we have another example here, maybe this one we have another output here, similar. Alright, similar like this. Okay, so this one also we cannot use the mismatch because we have 1 and 2. That means we have two value here, so still not valid. Okay, similar like this one. For example, if we have similar, okay, we have not 1, okay, we have 2. For example, this one and this one will be same. Okay, 1 and this one will be same, so we cannot use the max. Okay, similar like this one. Similar like this one, we have this one, one and another one here, so we cannot use the mismatch. It's only one. Okay, only one output only. All right, for example, this cancel this one, so the formula will be this one. This point, okay, plus this point divided by 2. Okay, okay, for example, this is our 4. This is 6, for example. So the Z output will be 4 plus 6 divided by 2, still 5. Okay, 5 go for our plan, our system. Okay, to our plan. So this is our mismatch. Okay, mismatch. Only one unique. Okay, only one non-unique value lah. Okay, if we have, for example, we have like this, another one here, same. That means we have one here and another one here, so we cannot use the mismatch lah. Okay, for example, okay, we have another one here. Okay, so this one like this. Okay, here. Okay, for example, here only point this one. Okay, so this one we can use the we can use the mismatch because this is only one for the maximum lah. Okay, maximum. Right, so this one is not maximum lah. Okay, this one maybe 0.8. Okay, so this is a maximum. So that's why the output will be here. This is our output lah. So the formula A plus B divide by 2. Okay, divide by 2. So that is the Z output lah for this using the mismatch. Okay. So next we try go for the exercise. Okay, you can see this is some exercise. Alright, so we have 4 methods. Okay, you can see this one. So this is output lah. Okay, so this is from for example, I draw like this. This is B1, this is B2, this is B3, and actually this is our B total lah. Alright, so first we have 4 methods. Okay, we can check which one we can use. Okay, so this one, all the method we can use center of gravity. Okay, so this one we can use the max we cannot use. Okay, this one cannot use the max because we can use either max or either with mismatch. So this one we cannot use the max, but we can use the mismatch. Okay, so this one we can use, and then weightage average. Weightage average, check is it symmetrical or not. Okay, for example, we assume this one. Okay, this one. Okay, we assume this is symmetrical lah. Okay, this is symmetrical. Okay, for example, same. Okay, right. So that's why we can use the weightage average lah. If this output is symmetrical lah. Okay, symmetrical. We assume this one is symmetrical. For example, it's a symmetrical. Okay, so if symmetrical, we can use 3 methods. This one. So we can use the center of gravity method with which average method and mismatch membership method. Okay, clear this one. So we can use either one lah. Okay, but for example, this one we can get the output for possibility lah. Possibility for the differentiation. We can use the center of gravity method, we can use the weight average method, or we can use the mismatch method. Okay, the simple one is the mismatch lah. Okay, the mismatch is the simple one, the fastest one lah. So this is the output. Okay, that means maybe this one is 7. I put a 7 here. This one is a 6 lah. Okay, this one is 7. Okay, 7 here. So Z here will be 6 plus 7 divided by 2, for example lah. Okay, the answer will be 6.5 lah, for example. Okay, so there is straightforward. Okay, for example, the mismatch is the straightforward lah. Okay, and then for example, for the weighted average, next we go for the weighted average. Okay, weighted average. So find the, for example, this is a center. Okay, this is center for B1. This is center for B2, for example. This is center for B3. Right. So Z total using the this one maybe 2.5. I assume this one 2.5. This one 5. This one will be 7 lah. Okay. So this one 2.5 multiplied by 0.3. Okay. Plus, okay, this one 5 multiplied by 0.5. Okay. Plus 7 multiplied by 1. Okay. Yeah. 7 multiplied by 1. Okay. This one 5 multiplied by 0.5. Okay. 2.5 multiplied by 0.3. Okay. Divide by membership value. So 0.3 plus 0.5 plus 1. Okay. That is the output lah. Okay. You can use the calculator to get the output here. Right. That is for weightage average. Okay. Next, weightage average lah. So last, we can use the center of gravity lah. Center of gravity will be take longer time lah because you have to do the integration. Okay. The first part. Okay. That means for the center of gravity, you have to remember this one. So we have 1 equation, 2 equation. Okay. 1 equation, 2 equation. We have 3, 4, 5, 6, 7. Okay, that means we have 7 equation. Equation 1, equation 2, 3, 4, 5, 6, 7. Okay. Okay, for example, to get the equation 1. Okay, to get the equation 1. Okay. this is integration. Okay, integration from, for example, from 0 to 1. Okay, from this one to this one. Okay, from 0 to 1. Okay, so to get the equation here, right, z minus 0. Okay, 1 minus 0. Okay, multiplied by 0.3. Okay, because of membership value here until 0.3. Okay, multiplied by z dz. Okay, z dz lah. Right. So this is for equation number 1. Equation number 1. Okay, and then equation number 2 will be here. So will be constant lah. Plus integration from this point to this point. Okay, this point to this point. Maybe I put maybe 3.5. Okay, from 1 to 3.5. Integration from 1 to 3.5. So the membership value is the 0.3 z dz. Okay, this is for equation number 2. Okay, and then for example, equation number 3 here. Equation number 3 will be like this. Okay, equation number 3, integration from maybe you can put as the 3.5. Okay, 3.5 to 4. For example, 4. Okay, then the equation here. Okay, so the equation you can put as the c minus 3 divided by 4 minus 3. Okay, okay, the membership value is a 0.5 z dz. Okay, this is for equation number 3. Okay, and then you can proceed for the equation number 4. Okay, only 4 from this point, 4 to maybe this one, maybe okay, maybe 5.6. Okay, 4 to 5.6. Okay, and then the membership value is 0.5. Okay, 0.5 z dz. Okay, and then so on until 7. Okay, until 7 equation. That means equation 1, equation 2, equation 3, equation 4 until equation 7. Okay, 7 here. Right, divide by, okay, will be same but cancel the z here. Okay, cancel the z. So for example, equation 1 will be same. Okay, z minus 0. Okay, 1. Okay, kosong 0.3 dz. Okay, we cancel z here. Okay, plus this is for equation 1. Okay, equation 2. Okay, so will be same. Just copy. Alright, but this one cancel the z. 0.3 dz. Okay, this one we have for the numerator, we have the z here. So on the denominator, we cancel the z here. Right? That is for the center of gravity lah. Alright, so let's we go one by one. Well, this is for example. Okay, that you can see this one. So 0 to 1. Okay, the integration from 0 to 1. This is membership value 0.3. Okay, like this 0.3. Okay, 0.3. So z dz. Okay, z dz here. And then so on lah. Okay, from 1 to 3.6. Okay, z dz. Similar like this lah. 1 z dz. Okay, question number 2. Okay, this one they put 3.6. Okay, it's okay. So this one 0.3 z dz. Similar like this one lah. 0.3 z dz. Same. Alright. So equation this one from 3.6 to 4. Okay, z minus 3. Okay, this one z minus 3 divide by 1 lah, because 4 minus 3 is 1. Okay, multiply by 0.5. Okay, 0.5 1 over 2 lah. That's why you can get 1 over 2. Okay, 1 over 2 z dz. Okay, next this one will be 0.5. Okay, that's why you can get here. Question number 4, 0.5 z dz. Similar like this one, 0.5 z dz. Okay, so and then this one will be divide. Okay, divide. Okay, you can see. So this one. Okay, divide. So we can cancel this one. Okay, this. Okay, we cancel this one. Okay, sorry, this one z. Okay, we cancel this z. Okay, on this part lah. Sorry, this one we have z here. Okay, so this one we cancel this one. You can see this one will be same. Okay, this equation will be same. The difference is this one is z dz. This one only z. Okay, only z. Similar like this one. The equation will be same, but this one will be cancel the z here. Okay, z here lah. Right. So this one no z here. The equation will be same. the intersection integration from point to point will be same. Okay, the value here will be same, but on this part will be different. So this one will be integrated by z dz, this one only dz. Okay, there is a difference between the numerator and denominator lah. Okay, so on the above we have the z dz. Okay, but on this one we don't have the z. Okay, cancel out the z. Okay, this one you can use your calculator lah. Okay, if your latest version for calculator, I think MS47 MS, I'm not sure. Okay, this one for all version you can use one by one. Okay, you can solve using the calculator one by one lah. If you use the latest version, you can solve all this equation into your calculator. Okay, you can use this your calculator to get the last value lah, the output here. Okay, alright, so for example like this one that I mentioned to you alright, so this is for weight average. Okay, weight average, okay, I mentioned to you 0.3 multiplied 2.5 plus 0.5 multiplied by 5, okay, plus y multiplied by 6.5 divided by membership value lah, 0.3 plus 0.5 plus 1, okay, plus 1. This is for membership value lah here. Here. So the answer will be, okay, using a calculator for 5.41 meters lah. Okay, that is also for example using the weighted average. Okay, this one, or you use the mismatch. Okay, use mismatch. This formula for using max. Okay, this is for example lah that I mentioned to you before this. Okay, 5 plus 7 divided by 2. Okay, the answer will be 6.5 meters lah. Okay, for example, this inverse of this course using the meters. Okay, that's why the answer will be 6.5 meters. Okay, that is using the mismatch. Okay, all right. So maybe we can try example lah. Okay, try example here. Okay, I'll open. Okay, all right. So try this one. Okay, so find z output using the all possible defuzzification methods. Okay, first, okay, we have 4 methods. We have the max, we have the weight average. Okay, I put as a weight average. So this is center of gravity, COG, center of gravity, and another one is the means max. Means max. I put the means max. So this one we can select which one we can use. We can use the max. Okay, this one we can use. Okay, center of gravity with all the output we can use the center of gravity. Okay, this one you cannot use the means max. Okay, means max we cannot use. And then weighted average, check is it the symmetrical or not. Okay, so for example, okay, this is symmetrical. We assume it's the symmetrical. So we can use 3 methods. Okay, we can use the max, we can use the weightage average, okay, weight average, and we can use the center of gravity. Okay, to solve this one, okay, the technique is solve the simple one. Okay, if you get this question, okay, this question, if you want to solve this one, you have to solve the simple one. Which one the simple? The simple one is the max. Okay, then weight average, then the last one is the center of gravity. Okay, make sure. So if you want to solve this output, okay, to get the z output, solve the simple one, because the question will be all possible defuzzification method lah. So we have 4 techniques. Okay, we have 4 techniques. Which one the possible? So for this case, this output be total here. So we can use the max, we can use the weight average, we can use center of gravity. Okay, for this one, the simplest method is the max. Automatically, this is the output. Okay, for example, this is our output. So our output will be, for example, 8. Okay, for max will be 8. That's why here you can get the simplest method lah using the max. Okay, next you have to solve using the weighted average. Okay, the first technique is to solve the simplest method. There is max or mismatch lah. Okay, either you have to solve using the mismatch or max. Okay, for example, if you have this one will be unique, non-unique, so we can use the mismatch lah. For example, this case we have to use the max. Okay, we cannot use the mismatch. Okay, mismatch we cannot use this one. So we have three possible lah. We have three possible method. So the simplest one is the max. So automatically, no need to use your calculator lah. So automatically from this point, you can get the output here. Okay, this is our output using the max. Okay, next we can use the center of gravity. We can use the weighted average. Second method is the weighted average. Okay, the weighted average. Okay, because of we assume this is symmetrical lah. Alright, so for example, okay, this one, okay, this one is the we call the B1, this one B2, this one B3 lah. Assume this B3. Okay, B1 So B1, the center will be 4. The center will be 4 multiplied by 0.5. Okay, plus second B2. B2 is the 4 multiplied by 0.7 plus, okay, center is 8 multiplied by 1. Okay, divide by 0.5, 0.7 plus 1. Okay, so using your calculator, you can get the value here lah. Okay. Okay, what is the value for this one? Using calculator, using your calculator to get the value here lah. Alright. Okay, so we have this one, for example, this we call a B1, this one B2, and this one B3 lah. Okay, so for example, B1, B1 the center maybe this. Okay, 4 multiplied by 0.5. Okay, for the membership value. Okay, for the B2, okay, the center is 4, and then multiplied by 0.7. Okay, that is for B2. And this one is the B3 lah. Okay, this one B3. Okay, so B3 will be center is the 8 multiplied by 1. Okay, multiplied by 1. Divide by all the membership value lah. So 0.5, 0.3, 0.7 plus 1. Right? Okay, so this is the using the weighted average. Okay, using the weighted average. Okay, if using the tough one is the center of gravity lah. So this will be take time. So normally student will be take time for this one to solve using the center of gravity. So that's why if you get this question, first answer the simplest one, the simplest method. Okay, for this case you have to solve using the max. Second, weighted average. Third, you have to solve this one. Make sure. So this is a previous mistake from the previous student. They have solved the center of gravity. So this one will be take time. So will be take time, and then student forget to solve the using this one, the weighted average, the max membership method lah. So that's why they are losing the mark. This one, this part and this part. Okay, because the question will be the question all possible method. Okay, we have 4. Which one the possible? So for this case, we have 3 possible method lah. We have the max, we have the weighted average, and we have the center of gravity. So that's why if you get this question, first solve the simple one. Okay, solve the simple one is the max. Okay, that's why first solve the simple one is the max. Second, average. Third, last one is the center of gravity. Okay, the last method is the using the center of gravity lah. Okay, if you get this question. Okay, next for the center of gravity. Okay, center of gravity, you have to make sure. So we have one question here, 2, 3, 4, 5, 6, 7, 8. Okay, we have 8 equation here. So maybe I just go for the equation number 1. Okay, for example, equation number 1. Okay, I put as a 1. Okay, from 0 to 2. Okay, from 0 to 2. Okay, put some z here. Z minus 0. Okay, z minus 0. Put here z minus 0 divide by 2. Okay, divide by 2 multiply by 0.5 here. 0.5 z dz. Okay, so this is for equation this one. Equation 1. Okay, for equation 2, equation 2 I put here. Right, from this point 2 until this one. Okay, we assume as the 3.5 lah. Okay, normally for the midterm, for the final, so normally this value will be given lah. Okay, this value will be given. Okay, this point will be given. Okay, suppose we have the standard answer lah. Okay, so that's why we give the value, for example, like this. Okay, 6.7 lah, we given the value here. Okay, for example, this value is 3.5. We assume from 2 to 3.5. Okay, the membership value is the 0.5 z dz. Okay, that is for equation 2. That means we have 8 equation lah. Okay, that we try for equation 3. Okay, next we try for equation 3. Okay, from 0.3, this one we assume as 3.5 to 4 to 4 here. Okay, this one is 4. Okay, so the equation here, okay, the equation, okay, that's why you can put this equation and this equation will be same slope lah. That's why you can put, okay, for example, like this one will be positive z minus 2 divide by 4 minus 2. 4 minus 2 will be 2. Okay, the membership value is 0.7 z dz lah. Okay, that is for equation 3. Okay, this one for equation this part. That's why we integrate from 3.5 to 5. That means we can get area under the graph here. Okay, under the graph here. So for example, this one, you select under the graph here. Area under the graph here. This part. So this part, we integrate, we can get this one, area under the graph lah, so we can get here. Okay, all right, so next question number 4, we try for the next question. Question number 4. All right, so from 4 to maybe we can put as the 4.5 lah. 4.5 normally will be given lah. Okay, will be standard will be standard answer lah. So okay, so this one, okay, we have 6 minus z divided by 6 minus 4. Okay, this means 6 minus 4 will be 2. The membership value is the, okay, 0.5. Okay, z dz. Right, so this is for question number 4 and question number 5. Try some until question number 5. So question number 5 will be like this. So from 4.5 to this one, maybe 6. Okay, 6 0.5 z dz lah. Okay, clear? So this one, so and you have to get until 8 until 8 equation. Divide, okay, divide, okay, after you get all 8 equation, divide by, okay, divide by, for example, divide by, okay, after you get all the equation, so the one will be same. Okay, for example, 0 to 2 z to 0.5 dz. Okay, so this one so cancel the z. Okay, plus straightforward will be same, but no, only dz 2 until 3.5. Okay, 0.5. Okay, dz. Okay, number 3, for example, number 3 from 3. Okay, for example, from 3.5 to 4. Okay, z minus 2 divided by 2, 0.7, okay, dz. Okay, so divide by, okay, you can see this one so I will cancel for the numerator, we cancel the z dz cancel z here, so only z, only dz here. equation will be same. We have 8 equation. Equation number 1, 2, 3. But the only for the denominator will be dz. Okay, that means dz lah. Only dz. So this one z dz. So this one only dz. Okay, and then use your calculator. After you get the all equation here, you get the 8 equation here. You can use your calculator to get the output here. Okay, so I give you 5 minutes. Try to this one. Try to get the z output. What is the z output for this one? Okay, so maybe you can try first. Try. I give you maybe 5 minutes. 5 minutes to get the answer here. Okay guys, ada dapat jawapan? Any answer for this one? Using the center of gravity. Okay, so this one, after you get all the equation for the 8 equation here, and then you can use, okay, you can use straightforward using your calculator lah. Okay, if you use the latest version for your calculator MS 57570 MS, okay, maybe you can solve all the equation lah into, you can substitute. But if you use the old version of the calculator, you can solve one by one. So you can solve this one. But the latest one, you can solve all the equation. Okay, all the equations. Okay, using into one single entering the data lah. So no need to use one by one. For all version, you have to use one by one. Okay. Okay, anyone get the answer for this one? Ada dapat jawapan tak? Alright, so if we get this one, so the tough is this one lah. The center of gravity is the tough one in the fuzzy logic lah. Okay, so that's why if you get this one, okay, this equation for this one, first you have to solve the simple one lah, the simple method lah. Okay, the simple method is before I mentioned to you, is the max, okay, or mismax, okay. Then you can use the weight average, okay. Then last is the center of gravity. Okay, do the simplest one first. Okay, if you do for example, like if you solve using the center of gravity, maybe you don't have the time to solve another one. For example, that's why sometimes the simple mistake, student forget to solve other methods. Okay, the question will be all possible method, okay, using the differentiation method. So first, if you start with the center of gravity, so normally student forget to solve using the other methods. Okay, that's why you have to read the question lah. So for example, this equation will be using all possible method lah. So that's why we have 4 method, which one the possible. So for this case, we have 3 methods possible to solve. to get the output. Okay, and then the technique is solve the simple one. First using the max or using the min max, then weighted average. The last one is the center of gravity. Okay, guys, clear this one? So this is a technique on the defuzzification technique lah. Actually, we have a lot of dimension. We have a lot of technique, but in our class we just focus on only 4 techniques lah. Okay, we focus on the 4 most common differentiation method lah. So there is the max, okay, weighted average, min max, and last one is the center of gravity. All right. Okay, class, any question so far? Okay, so maybe after this you have to try lah using to solve the center of gravity using your calculator. Try using your calculator. Okay, because before this student can use the calculator lah to solve the integration. Okay, integration okay, using your calculator lah. Okay, straightforward using your calculator. But you have to write the equation. All right, so for example, like before this we have 8. Okay, we have 8 equation, so you have to write the 8 equation for numerator and denominator. Then you can use your calculator to get the last answer lah. What is the Z output? Okay. All right, so that's why you can try. I will give okay for this equation. So next I will give the example. You can try lah. Okay. All right. Class, any questions so far? Okay. Boleh ya?
Boleh ada.
Okay, so you can try lah. After this, you can try. I will give some example. So you can okay, use your mathematics okay background. So to solve the integration lah. The tough one is the center of gravity lah, because of a lot of equation you have to solve lah. For example, before this we have 8. Okay, we have 8 equation you can solve. You have to solve lah. So that's why on the falsification techniques, the tough one is the center of gravity lah. The rest is straightforward. Okay, for example, like inference engine using the max min, okay, fuzzy set. Okay, that is straightforward mathematics. But the tough one is the center of gravity lah on the defuzzification techniques. Alright, so I will stop here. Alright, so maybe after this I will give the example for the defuzzification techniques, so you can try right to get the output. And then next week we can so next week class we focus on the how to design the fuzzy logic using the MATLAB. Okay, how to design the fuzzy logic using the MATLAB. So we go, hopefully all of you have the MATLAB okay already installed on your laptop. So next week I will explain step by step to design the fuzzy logic controller or fuzzy logic control using the MATLAB. Okay, using the MATLAB lah. One by one step. You have to first, okay, you have to design the input outputs, okay, that mentioned to you before this. And then set, you want to use the Sugino or Mamdani lah that I mentioned to you. So in our class we have the Mamdani and Laksen, okay, but on the MATLAB they have only Mamdani and Sugino. So next week I will explain what is the difference between the Sugino. Okay, what is the difference? Sugino lah, Mamdani and Sugino. Okay, all right. So make sure if try to install the MATLAB, so you can try lah after this. So next week our class will be focused on how to design the fuzzy logic controller using the MATLAB software. Okay, right class. If not question, so I will stop here. All right, so thank you very much and see you next week. So happy Deepavali to all of who celebrate the Deepavali. All right, so see you next week. Okay, thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
Letak attendance isi yang link tu je kan?
Ya, isi yang link tu saja.